Welcome everyone to the SAEON seminar series. Thank you so much for joining us this afternoon. My name is Kinelo Hlahane and I'm from SAEON uLwazi node, and I will be facilitating this session for today. I will start off first with some house rules. If you noted that this meeting will be recorded and the recording will be made available on the SAEON's YouTube channel after the meeting. And at the end of the session, I would also be moderating the Q&A session. So please do pop in your questions in the chat and they will all be answered after the speaker has presented. Now I'm going to start by presenting our speaker for today. We have Mark Jacobson from the uLwazi node. Mark is a systems development lead at the uLwazi node, and he has been with SAEON since 2017, starting off as a contractor, but now he's the systems development lead. He's a Python and Linux enthusiast with over 20 years of systems development. He holds a BSc Computer Science in Mathematics. He holds a BSc in Mathematics and Computer Science from UCT and an honors degree in Ocean and Atmosphere Science. He has worked in a variety of industries in South Africa and the UK. And I also added some fun facts about Mark so that we can get to know our presenter a little bit more. One fun fact about him is that he has volunteered in wildlife conservation projects around the globe, one of them being counting corals in the Caribbean, and the second one being counting condors in Patagonia. So without any further ado, I would like to give our speaker for the day, Mark Jacobson, the floor. Mark, you can carry on.
Thank you so much, Kinelo, for the introduction, and good afternoon, everyone. I'd like to begin with a bird's eye view of the SAEON data landscape. Now, this picture is by no means intended to be a comprehensive account of SAEON's data holdings and workflows. It's intended to present a high-level perspective on terrestrial and coastal observational data with a focus on terrestrial and the workflows surrounding the preservation and publication of this data. The solid arrows on the diagram indicate well-established workflows, while the dashed arrows indicate intermittent and not so well-established workflows. SAEON's Loginet server is an interesting case, and it has become something of a focal point in the recently initiated drive to mobilize the wealth of data that is otherwise gathering dust on SAEON's backend storage servers. Loginet is a program used by SAEON technicians to download data from field instruments, to monitor the operational health of field instruments, to visualize and quality check data, and even to publish data to live weather websites. Back in 2013, after endless struggles with poor cellular connections in the field, a Loginet server was set up and configured to automatically download data from the remote terrestrial sites at regular intervals. Now, the total volume of data on the Loginet server is actually not a huge amount. It's only around 5.5 gigabytes. The bulk of the data being generated as we speak is coming from the more advanced flux towers that are installed at a few of these sites. The flux towers generate more than 100 megabytes per site per day, and this is currently too much for the automated download bandwidth. So what happens is that the flux data is saved to a memory card in the data logger until the technician downloads it manually. The manually downloaded data is then transferred either to a node file storage server or to SAEON cloud storage. Requests for access to terrestrial observational data by researchers and students are fulfilled on an ad hoc basis. In these cases, a SAEON technician will typically create a shareable dataset by extracting the requested variables over the requested timeframe from the applicable data source. With the assistance of the uLwazi curation team, a metadata record will be created along with the DOI, Digital Object Identifier. The dataset will be archived and shared by the SAEON repository, and the dataset will be published via the SAEON Open Data Platform to local and global data catalogs. Now, one of the challenges that SAEON faces is that this kind of ad hoc provisioning and publication of data is not even remotely scalable to the kinds of volumes of data being collected by the terrestrial data logger network. But before we start looking into automating and scaling up data publication, Let's take a look at the ODP publication workflow. First up, though, a bit of history about ODP development. Up until 2021, SAEON hosted datasets were published via SASD, the South African Spatial Data Infrastructure. Now, the SASD services and underlying clone content management system had been around for a number of years and suffered from numerous problems, including poor security, limited support for data curation workflows, and very limited metadata validation. ODP version 1 development was largely driven by two major use cases, the SAEON Observations Database and the Marine Information Management System, and it introduced a number of innovations. In version 1, we introduced JSON schema-based metadata validation, which resolved a whole host of quality issues with SASD metadata, the ISO 19115 metadata standard in support of the Marine Information Management System, and a JSON translation mechanism for transforming ISO 19115 metadata to the DataSite standard, thus harmonizing metadata outputs at the ODP catalog endpoint and enabling MIMS metadata to be published to DataSite. ODP version 2 then took lessons learned through the development and production operation of version 1, bringing improvements on a number of fronts to performance, security, scalability, and extensibility. The major innovations of ODP version 2 center around the publication workflow, with support for multiple and diverse data catalogs and a versatile metadata tagging framework. In ODP version 1, the publication workflow was linear. Any metadata put into the system, whether automatically from the SAEON Observations database or manually by a curator, was essentially the same metadata that would come out at the catalog endpoint. What we found was that this process was sometimes too rigid for the variety of use cases that we have to support, and it often required various workarounds to get things published to different flavors of catalog. If we look at the ODP version 2 publication workflow, it doesn't look a great deal different from ODP version 1. In fact, the only difference from this perspective is that we've changed the singular catalog to the plural catalogs. From a systems modeling perspective, however, this is actually quite a profound change. And to understand this, we need to get a little bit more technical and take a look at the ODP data model, the entity relationship model in technical terms. ODP version 2 introduces the concept of a generic catalog, and the catalog has a multi-way relationship with the ODP metadata record. This is also known as a many-to-many relationship. Now let's zoom in on the catalog record relationship. In the expanded notation, we can visualize the many-to-many connector as two separate one-to-many relationships with the catalog record association table in between. What this association table allows is a distinct published record for every catalog instance. So while we can still take advantage of common publication infrastructure and processes that apply to publication of records to any catalog, we now have the freedom to customize the publication pipeline to suit each specific instance of catalog that we support. In the particular example shown on screen, which shows a record for a Sava dataset, we see that we can create slightly different versions of this for the SAEON catalog and for the record that we publish to DataSite. And in this particular case, we see that the record is excluded altogether from the MIMS catalog. ODP version 2 introduces another new concept, the tag. A tag is a structured annotation that can be attached to a record or collection to provide additional contextual information, such as quality checks, readiness for publication, curation notes, record retraction and embargoes, and so on and so forth. Each type of tag has its own JSON schema that precisely defines the structure of information that may be attached to a record or collection by such a tag. Some tags may be associated with their vocabulary. For example, we've recently implemented SDG tags, SDG being United Nations Sustainable Development Goal, which is associated with the SDG vocabulary. Now let's zoom in again, this time to the record tag many-to-many relationship. Using the same example of a Sava record, we've attached 3 tag instances to this record. One is a QC or quality control tag, and it's been attached with the value of past. The other 2 tags are instances of the SDG tag type with values referencing keywords from the SDG vocabulary. This particular Sava record relates to data about agricultural crop survival in relation to temperature variability. So we've tagged the record with SDG 2, which is about hunger and food security, and with SDG 15, which is about sustainable use of terrestrial ecosystems, amongst other things. In general, tags provide a way of extending the functionality of the system without having to change the underlying data model. We've already implemented over a dozen different tag types of widely varying uses, and the potential use cases are virtually limitless. Some tags, like the quality control tag, influence the record publication process. Others, like the SDG tag, may have applications in a data science context. The great thing about tags is that they are generally relatively quick and easy to implement. While some custom code is always required for a tag implementation, the underlying ODP tag framework does a lot of the work for you. On this slide, we see a few examples of the kind of configuration that is needed to set up a new tag. Looking at the collection published tag, we see that it has a cardinality of 1, indicating that only one such tag may be set on a given collection. It only makes sense to set a single tag on a collection, indicating that it is ready for publication. The record QC tag, on the other hand, has a cardinality of user, which means that multiple QC tags may be attached to a given record, but only one such tag per user. The same person can't say they've both passed and failed a record. The SDG tag has cardinality multi, meaning that any number of SDG tag instances may be attached to a given record by any number of users. The public flag indicates where the tag instances are propagated to published catalog records. In these examples, only the SDG tag becomes publicly visible. The others are only used internally to control the publication process. Every tag is defined with a unique scope, which indicates a permission that is required to be able to attach or detach such a tag to or from a record or collection. In these examples, the permission scope associated with the collection published and record QC tags will typically only be available to the curator role, while the permission scope associated with the SDG tag might also be available to data scientists. The tag schema defines the structure of any data associated with the tag instance. A simple tag like collection published uses the basic generic tag schema, which doesn't actually require any additional data, but it does allow an optional comment. The schema for record QC tags requires a true or false to indicate whether a record has passed or failed the quality check. And the schema for the SDG tag is a generic keyword tag schema, which requires a reference to a vocabulary and to a term or keyword within that vocabulary. Finally, the record SDG tag also defines a link to the SDG vocabulary. There are, in fact, a lot of potential use cases for such keyword tag implementations, which could, for example, allow us to better manage keywords associated with datasets. Keyword tag and vocabulary development is something we'll be exploring further going forward. Returning to the publication workflow diagram, aside from the pluralizing of catalogs, this still looks superficially much like the linear publication workflow of ODP version 1, in which it was basically up to the curator to bump a record along its way to the catalog endpoint. But if we expand this out a bit, we get a better sense of the separation of metadata management and metadata publication. In fact, in ODP version 2, curation and publication are orthogonal processes. Publication is fully automated, and curation activity is carried out entirely independently of publication. The multi-way relationship between metadata records and catalogs allows us to create output records that are independent of the metadata management records and that are suited specifically to each catalog instance. This approach, which derives from a principle known as separation of concerns in computer science, furthermore lays out a clear path to integration with any external data catalog. Two that have come up in recent conversations are integration with the OSIMS platform, that's the South African National Oceans and Coastal Information Management System, and OceanOps, a global network which has expressed an interest in harvesting metadata for SAEON's coastal datasets. In the case of OSIMS, there's a requirement for us to provide metadata in a standardized XML format rather than JSON. This can be done simply by extending the generic catalog implementation for the OSIMS case with methods for translating JSON metadata to XML, saving the XML as the published output for OSIMS, and adding an XML endpoint to the catalog API. Now, these are certainly not straightforward tasks, but the publication framework enables us to identify exactly what needs to be done to achieve this integration. Now, coming back to the high-level perspective on the SAEON data landscape, let's focus our attention again on the Loginet server and on one particular issue. SAEON's Loginet server is publicly accessible on the loginet.saeon.ac.za domain, and we know that data is being downloaded at a number of external institutions. However, we currently have no insight into the numbers of individuals or institutions that are downloading the data, what exactly they are downloading, how much is being downloaded, or to what end the data is ultimately being used. This represents a noteworthy gap when it comes to reporting on SAEON's data usage. Now, if we solve the problem of automatically publishing all of SAEON's terrestrial logger data, and I'll get onto the discussion of that shortly, then by way of published metadata records, we are inherently providing a mechanism for external individuals and institutions to find, access, reuse, and cite that data as needed and in a way that can systematically be reported on within SAEON and NRF accounting structures. This presents a strong argument for simply switching off the direct and unaccountable access to the Loginet Web API. However, it's important to recognize that direct public access to SAEON's Loginet server is clearly of benefit in one way or another to the wider research community. And rather than simply shutting down public access, we should consider implementing a mechanism for authenticating and tracking data access requests to facilitate reporting. Furthermore, direct public access to the Loginet data may in fact be critically important to the development of real-time data products, something that the data scientists within SAEON are actively working on. In fact, we should consider not only real-time SAEON data products, but even the possibilities that can be explored through establishing real-time data pipelines to external institutions. So now that we've established that it's a good idea to leave the Loginet backdoor open, so to speak, how do we go about tracking data requests and reporting on data usage? This diagram illustrates how we can transparently intercept and log requests for Loginet data. We have in fact already established a working prototype of an intercept and authenticate mechanism with respect to SAEON's threads catalog, which is why threads is shown in the picture. In principle, this mechanism can be deployed to intercept and log data requests for any data storage system hosted by SAEON. The key change from the current Loginet setup is to take the Loginet server itself off the public internet and only make it available via an internal loginet.saeon.int domain. The public domain, loginet.saeon.ac.za, is then reconfigured to redirect the caller, that is, anyone requesting data from the outside, to the Loginet endpoint of the ODP. This endpoint is in turn handled by Ori Oathkeeper, an open source proxy service that gives us the ability to plug in our own authorization handlers to decide whether or not to allow a request to be forwarded to the destination server. How this works from an end user perspective is that anyone wishing to access Loginet or Threads data would have to first log in via the ODP web application and identity service. Then when the user tries to browse any Loginet or Threads user interfaces, the Oathkeeper proxy checks with the ODP web application whether the user is currently logged in. And if they are, transparently allows the request to proceed. From a user perspective, they'll be interacting directly with the Loginet or Threads user interface. In reality, external users accessing either Loginet or Threads data are more likely to do so via Python or R scripts than by browsing and manually downloading data. And the Oathkeeper proxy, integrated with ODP systems, can adequately cater to this use case too. The only change from an end user perspective would be that the prospective data user would have to first log into the ODP web app, copy an access token that is generated for them, and paste this reusable access token into an authorization header at the point in their script where they make a data request. And so we are able to capture and log data access requests to any server which is routed through this proxy system. Ultimately, the information that we harvest in this way can feed into data usage reporting. Now, there remain significant questions around the reporting perspective, notably that there are existing reporting workflows which do account for a large proportion of SAEON's data usage reporting. And the kind of approach that I'm showing here could lead to overlaps in reporting that might be difficult to reconcile. But what I'm trying to demonstrate is that there is a way to close the gaps, to account for data usage that presently is unaccounted for. Now I'd like to discuss one final question. How do we go about automating and scaling up publication of terrestrial logger data? This is a complex and multifaceted problem. There's quite literally data sitting all over the place at SAEON. And what I'm going to present now is not a solution, but rather some insights from a systems modeling perspective that might help us to better understand the problem and potentially help us to think about how we can break it down into more manageable tasks and deliverables. Now, first of all, it's worth noting that the SAEON Observations database has already established an automated metadata pipeline to the SAEON Open Data Platform. Combined with well-established data processing and archival workflows implemented by the SMACRE and L1-led teams, the SAEON Observations database represents a kind of reference implementation of a general model that we can call the archive, Currently, however, the ODP has no notion of an archive. If we take a look at the publication workflow again from an ODP perspective, the observations database is simply a client that deposits metadata at the record API endpoint. And to the ODP, it's actually no different from a curator manually creating a metadata record via the ODP admin interface. But if we start bringing the terrestrial and speculatively a few other potential future archives into the picture, each with its own metadata pipeline to the ODP, then what begins to emerge is a problem not dissimilar to that of the ODP version 1 publication workflow, in which we had a single ODP catalog table that struggled to accommodate the variety of catalog applications that we support. While the observations database does a very good job of creating and updating its metadata records, looking ahead, we're faced potentially with an overwhelming deluge of metadata being written directly to the ODP metadata management records with no explicit change management, even though we do keep audit logs of all changes, and very little curation oversight. Notice also the incongruity of the curator sitting there amongst all the automated pipelines writing to the record API. This further suggests that we might be violating that separation of concerns principle that I touched on earlier. At this point, it's worth taking a look at some recommended best practices. The Open Archival Information System is a reference model that has been adopted by the uLwazi curation team as a best practice standard to work towards in terms of SAEON data preservation policy. And the OAIS provides some insight into how we might approach this problem. The OAIS defines 3 distinct representations of a data package. Now, a data package comprises of a dataset and its associated metadata. In terms of the metadata, which is stored in the ODP, we do distinguish between the archival information package, which in fact corresponds with the ODP internal record, and the dissemination information package, which corresponds with the catalog output record. But the ODP currently has no notion of a distinct submission information package, which is the data and metadata provided by a data producer. In the case of ad hoc manual data submissions, the curation team does in fact treat submission and archival information packages distinctly. In many cases, the submitted dataset is in fact the same as the dataset that gets archived, but the model and the derived curation workflow do allow for a submitted dataset to go through format translation, for example, when necessary to align with SAEON-supported storage facilities. But currently, this submission to archival part of the curation workflow happens out of band with respect to the ODP metadata management system. Now, considering the OAIS model, along with this aspect of the curation workflow, let's take a look at how we might model the distinction between metadata associated with a submission information package and metadata associated with an archival information package. So what I've done here is to add an archive entity to the ODP data model at the top right of the entity relationship diagram. And similarly to the catalog record integration, this has a multi-way relationship with the ODP record, with an archive record association table that now becomes storage for input metadata corresponding with submission information packages. And this separation of submission and archival metadata immediately gives us a whole new dimension to work with. Some of the things that we could potentially look at, for example, are versioning of metadata submissions, which gives us explicit change management and the possibility of choosing different methods of dealing with metadata updates from automated pipelines, depending on the nature of the archive and the nature of the integration. We could potentially more easily support archive mirroring and migrations. We could even consider the possibility of an archive having its own metadata schema, which would allow its pipeline to submit metadata that might be differently structured, perhaps simpler or better suited to the archive's data than their internal ODP metadata record. So the simple notion of creating a generic model of an archive enables us to separate metadata submission from metadata management. And this in turn gives us the flexibility to develop pipelines and workflows and integrations that are customized to suit particular instances of archival storage facility, which ultimately provides a strategic pathway to integration and publication of data hosted by any archive. To conclude this presentation, I'd like to propose a strategy for partitioning the SAEON data integration problem into well-defined and manageable components. This requires, firstly, identifying and naming the archives that we want to build, recognizing that each archive is a standalone data product in its own right, and that it's the single source of truth for the data that it hosts. We can also set further parameters or constraints around the purpose and the function of each archive, for example, that it might host only a specific processing level of data. We certainly don't have to decide on all the archives that we might need up front, but there are a couple of good candidates that can serve as starting points. The SAEON Observations database can serve initially as a reference implementation. It's well managed, it has dedicated resources, and well-established workflows and pipelines. And these are the kinds of things that we need to consider if we want to develop the Loginet server, for example, into a fully fledged archive. Thank you very much.
Thank you so much, Mark, for the interesting talk. It's quite insightful to see what goes on behind the SAEON Open Data Platform. And I hope everyone can now understand what we do at uLwazi.